Today's episode takes us inside the world of wow interesting skills and introduces us to an extraordinary concrete mixer in action. The construction of a concrete mixer truck drum is a blend of complex engineering and practical craftsmanship. It merges essential metalworking techniques with mechanical designs built for toughness, performance, and easy servicing. The process starts by fusing metal sheets through welding. Steel sheets are selected and prepared, chosen specifically for their durability and ability to endure the abrasive demands of concrete mixing. To hold the sheets in place during handling, spot welding is used first. This method temporarily tacks the sheets together, reducing the chance of shifting or misalignment. Once the sheets are welded, they're moved to a rolling machine. This equipment carefully bends the welded panels into a cylindrical drum shape. Welding first, then rolling, helps prevent seam warping and ensures the drum maintains structural integrity. This sequence produces a well-aligned, nearly perfect cylinder, crucial for smooth, balanced spinning when mounted on the truck. Workers manually guide the edges to meet precisely, maintaining clean, even joints. As the cylindrical drum takes form, a critical parallel task begins, the creation of the internal mixing system. This involves designing and fabricating the helical blades that will power the mixing action. These spiraled fins are crafted from high-strength steel, usually slightly thinner than the drum's exterior walls. Because these components face relentless abrasion, materials like hardox or other wear-resistant alloys are often used. With all parts formed, it's time for precision assembly. Sections of the drum are aligned with a calculated gap between them. This small space allows workers to fine-tune the alignment for an exact fit. Special clamps are then used to pull the sections together gradually. These tools apply even, localized pressure, closing the gap without warping the drum's round shape. At this stage, special attention is given to the front and rear ends of the drum. These end caps aren't just for sealing. They're essential for the structure and function of the entire mixer. Achieving accurate placement is essential to maintain proper alignment and fit. Even the slightest misalignment here could throw off the drum's balance and interfere with the function of the mixing blades inside. To prevent such issues, temporary clamps are positioned around the joint, and small tack welds are applied in stages. Next comes the full welding process, which follows a strict and carefully planned sequence. Tack welds lock the cap in place while full-length welds are gradually completed around the perimeter. Multiple weld passes are performed to ensure the welds penetrate deeply and create a strong, lasting bond. Filler welds are layered to increase strength and absorb the repeated stress the drum will endure in use. You'll notice that the welds are done in a circular and balanced pattern. This helps spread heat evenly, reducing the chance of warping due to expansion and cooling during the welding process. With the drum's outer shell now fully constructed, focus shifts to installing the internal helical blades. This step begins with creating precise guide points along the drum's inner surface. Technicians take accurate measurements and mark both vertical and circular lines inside the drum. These markings serve as guides to ensure the blades are installed at the correct spiral angle and orientation. Accuracy is key. Any errors in marking will disrupt the blade pattern and reduce mixing performance and balance. To help with layout, the blades are made from specially prepared steel strips. Each strip is bent to match the curvature of the drum and twisted into its final spiral form. This forming step demands skill, as improper shaping can cause inconsistent mixing action. These initial tack welds act as temporary anchors for the blades, allowing for slight repositioning if necessary. After confirming that the blade alignment is accurate along the full spiral track, final welding begins. This stage firmly secures the blades to the drum's interior with continuous seam welds. Welders must ensure a solid bond without allowing the weld to overpenetrate and weaken the surrounding structure. As the drum spins, centrifugal force drives the concrete outward, pressing it firmly against the inner drum wall. This creates powerful radial pressure that directly impacts the surface area of the helical blades. As a result, the blades experience considerable sideways stress, which attempts to bend or distort them outward. Simultaneously, aggregate particles like stones, sand, and gravel strike, grind, and slide against the blade surfaces during mixing. This continuous friction slowly wears down the blade thickness, compromising strength over time. The added reinforcements serve to resist such wear and distortion, helping preserve blade shape and consistent mixing performance. Once the drum's internal structure is finalized, focus transitions to building the external support frame. The first step in this phase involves cutting heavy-duty attachment plates from thick mild steel sheets. These plates serve dual purposes, reinforcing the drum's rear section and providing solid anchors for mounting hardware. Oxyfuel torches are used to cut these plates, allowing for accurate shaping of internal holes and external contours. After cutting, The plates are cleaned thoroughly to eliminate slag and burrs left by the torch. Each plate is inspected carefully to verify smooth edges and proper flatness, ensuring clean fits with connected parts. These components are then positioned at the rear of the drum, where the support frame begins to take shape. Proper alignment at this stage is vital, so tools like mechanical squares, steel tapes, and chalk lines are used to confirm accuracy. The team checks that all components are square and centered in relation to the drum's axis of rotation. Since the drum acts as a rotating mass, even small misalignments can create severe imbalance issues during operation. Ensuring symmetry around the axis guarantees that the drum rotates evenly and avoids vibration or stress concentrations. Such irregularities might eventually lead to fatigue fractures, loose hardware, or catastrophic failure of the structure itself. At this stage, the crew has verified all prior alignments and begins positioning the upper load-bearing plates. These vital components not only seal off the drum structure from above, they also function as the key mechanical link between the rotating drum shell and the drive mechanism responsible for its movement. During this phase, welds must achieve complete structural fusion, with consistent heat control and uniform bead formation. Every weld is closely inspected by eye to detect any imperfections or signs of weakness. When flaws are identified, expert welders step in to grind out irregularities and add reinforcing weld passes where needed. As the build nears its final stages, attention turns to fabricating the discharge chute and its related mounting structures. These arched assemblies are shaped to precisely match the curvature of the drum's exit area. Sheet metal panels are cut with high accuracy, bent into form, and welded together to create the curved chute. Special fixtures and alignment tools are used to ensure that the chute maintains a true and consistent profile. This prevents warping or misalignment that could disrupt the smooth flow of material during discharge. At the same time, the chute's support arms and side brackets are being assembled. These sturdy arms are designed to secure the chute during use. They also provide a mechanism for swiveling and locking the chute into position, adapting to different site layouts or poor angles. The base plates used for these attachments are built from thick, reinforced steel. To enhance their load-bearing capacity, flanged edges and gusset reinforcements are welded at key stress locations. In parallel, the team continues work on preparing the drive system's interface. The planetary gear reducer, a vital part of the drum's hydraulic propulsion unit, is suspended into place and aligned precisely with the drum's drive hub. Extreme precision is required here. Any misalignment or tilt would cause uneven stress on the gearing system. Workers use rigging equipment like chain hoists and adjustable supports to fine-tune the gear reducer's position. Its alignment must be true not only to its own axis of rotation, but also to the frame of the vehicle it will be mounted on. One of the critical stages at this point involves applying protective paint layers. While painting might seem cosmetic to an untrained observer, it actually fulfills several crucial engineering purposes. Once the newly built steel drum is exposed to air, it becomes highly susceptible to corrosion. To prevent this, industrial-grade coatings are applied, typically starting with thick epoxy primers, followed by a polyurethane top layer. Equally vital to the overall construction is the addition of side-mounted platforms along the mixer frame. Operators often need to reach the drum's loading and unloading systems to assess mix consistency. They also need access for adjusting the discharge chute, regulating added water, or clearing occasional aggregate blockages. Safe and reliable access is essential for performing these tasks, especially given the drum's elevation above the ground. After each job, thorough cleaning is mandatory to stop concrete from hardening inside the drum. These cleanouts require operators to stand securely beside the drum while using high-pressure hoses. Without properly constructed platforms and protective rails, these tasks would pose serious risks of falls or injury. In fact, many global safety guidelines, including OSHA, ISO, and EN standards, require any elevated work near rotating systems to be performed from certified, secure platforms. In some mixer designs, these platforms also double as mounting zones for secondary units like water reservoirs. However, beyond surface coatings, the machine's core structure must be built to withstand extreme stresses. As previously noted, this is necessary because of the continuous mechanical and chemical strain placed on it. A concrete mixer doesn't just sit in place. It acts like a mobile mixing chamber, in constant motion with heavy semi-fluid contents. All of this occurs while the unit endures road vibrations, impacts, and terrain-induced shock loads. The rotating drum is essential for keeping the concrete mix uniform by stopping the separation of aggregates. If the drum stops turning, the concrete may begin to set unevenly and irreversibly within the drum. This would ruin the batch entirely and potentially inflict serious damage on the drum's inner walls. Since a fully loaded drum can weigh several tons, including both its structure and the concrete contents, the frame must be engineered to handle a wide array of constantly changing mechanical stresses. To further reinforce these areas, all seams and welded joints are treated with body filler compounds. These fillers are meticulously applied to corners, edges, and weld lines. Anywhere minor surface gaps or irregularities occur. This method helps eliminate structural vulnerabilities that might otherwise trap moisture, dirt, or corrosive agents. Factors that can rapidly accelerate rusting. Next, the hydraulic oil reservoir is a critical component in ensuring the smooth operation of the hydraulic system. Hydraulic motors depend on a consistent supply of pressurized oil, and the reservoir not only acts as a storage tank for this fluid. It also contributes to heat dissipation, air bubble removal, and filtering of contaminants. A faulty or absent reservoir would cause the hydraulic system to overheat and malfunction in short order. Mounting the reservoir requires careful fabrication of support brackets to guarantee secure installation and operational stability. This entire concrete mixer truck was built locally in Pakistan. Even without access to advanced robotic systems or high-precision CNC tools commonly found in modern factories, the builders depend on deep practical experience, accurate manual labor, and strong mechanical instincts. This type of construction is generally classified as artisan-intensive fabrication. It involves applying technical know-how through largely manual, hands-on processes. The workshop uses a basic toolkit, often centered around portable welders for assembling key structures. Instead of automated precision, every dimension, cut, and weld is directly influenced by the craftsperson's interpretation of technical drawings. Even intricate parts like helical screw blades and rotating bearing housings are created with analog measuring instruments. What's impressive about this method isn't the simplicity of the tools used. It's the precise control over assembly, load distribution, and stress points that the workers consistently achieve. Such tasks demand a strong grasp of both the mechanical properties of materials and the forces acting on them in real-world use. The builders are essentially performing complex mechanical problem-solving using knowledge built from years of hands-on experience. This kind of small-scale fabrication isn't exclusive to Pakistan. It's a common technique, found in numerous emerging industrial regions across South Asia, the Middle East, and the African continent. It makes it possible to build and repair equipment that's tailored to specific local conditions and challenges. The method offers a cost-effective solution, but relies heavily on the expertise of skilled technicians. although it may seem less precise compared to fully automated, high-tech production lines. The manual process remains extremely demanding in terms of technical accuracy and craftsmanship. It reflects a flexible, skill-driven manufacturing approach that thrives even when advanced infrastructure is limited. Certainly, here's a rewritten version with the same structure and separation maintained. In this setting, the use of CNC machining centers, robotic welders, and automated inspection systems is not financially feasible. Rather, accuracy and quality are maintained through the seasoned hands and sharp judgment of experienced craftsmen, as demonstrated. These individuals embody a wealth of mechanical know-how passed down through years of practical work. Moreover, relying on manual techniques does not hinder the ability to manufacture robust and long-lasting equipment. In reality, concrete mixer trucks built this way are frequently deployed in extremely demanding environments. Their impressive service life is largely owed to intentionally cautious and rugged engineering choices.